This video presents a Trinity use case focusing on methods for safe and agile human-robot collaboration in large-scale material handling, processing, prefabrication and assembly tasks. We will also present a dynamic way for creating robot trajectories. Our solutions provide an agile way of utilizing industrial robots in human-robot collaboration applications. Next, we will present how this Trinity solution contributes to agile manufacturing, what are the actual benefits of this solution in agile manufacturing, application scenarios and scale of investment required in order to utilize this solution. And lastly, we will provide short conclusions of this use case. Agile, fenceless human-robot collaborative solutions are needed for large-scale robotic applications where manipulated objects are often physically large and heavy. Agile and safe manufacturing solutions require comprehensive task planning, reactive robot programming, and hybrid safety system consisting of different types of safety devices such as laser scanners, safety light curtains, and safety cameras. Benefits of this use case approach are safe collaboration of high payload industrial robots and human workers, and also dynamic trajectory generation for variable work objects. We will now present these mentioned benefits in more detail. Safe collaboration enables that human workers can share workspace and work tasks with industrial robots in a safe manner. Dynamic safety solutions improve productivity by allowing high payload industrial robots to collaborate with human workers. Robot cell footprint can also be reduced due to flexible hybrid safety system. Traditionally, safety solutions rely on isolating robot working area from human working area by fences. This use case presents methods for more dynamic and safe collaboration between human and robot workers with fewer fences and more open access to robot working area. Easily accessible operation increases possibilities for utilizing robots and decreases footprint of a robot cell. Flexible collaboration between human and robot workers also increases productivity and decreases time required for setups. Increased productivity and short setup times result in increased profit. Safety devices can also be configured to allow only mobile robot to pass in the industrial robot working area. Benefits of dynamic trajectory generation are reduced time required for robot programming, and even small production batches can be profitable with reactive programming. This use case presents ways for dynamic creation of robot trajectories. Dynamic creation by scanning work object has a potential to reduce time required for programming robots before processing. Tasks such as painting, washing and sandblasting of large-scale objects can benefit this reactive way of programming. Dynamic creation of robot trajectories leads to shorter programming times and increases in profitability. Let's have a look at possible application scenarios for this use case. Through human collaboration and dynamic trajectory generation provide agility and flexibility in large-scale handling and assembly tasks. Goal is to improve profit, productivity and lead time. Goal can be achieved by two methods: flexible human-robot collaboration by utilizing devices enabling dynamic definition of safety areas, and dynamic creation of robot trajectories by utilizing reactive programming methods provided. Solutions provided here scale to various company sizes, especially safety solutions demonstrated can be applied to many different industries and tasks. Let's have a look at scale of investments. Hardware investments range from €1,000 to tens of thousands of euros per robot cell, depending on how many safety devices are required. Automap software for reactive trajectory programming costs are project specific and depend highly on the features needed. This Trinity use case approach provides methods for efficient human-robot collaboration by utilizing dynamic safety areas. Approach also enables flexible manufacturing of small production batches by providing tools for dynamic creation of robot trajectories. If you would like to know more, please have a look at our more detailed training materials. Thank you for your interest in this Trinity use case video.